our discussion for EAMCET and other objective exams like NEET. Our chapter today is vectors and scalars. Vectors and scalars is also one of the important chapters in physics, which covers the whole gambit of physics. Here, unless students are perfectly okay with the application of vectors, he cannot be comfortable in physics. So let us see what is actually the criteria in vectors and scalars, how we apply these vectors and scalars to do various operations in physics. All this we will discuss today. Any quantity in physics, we have so many physical quantities. Some have direction, some have only magnitude, some have both direction and magnitude. So to distinguish them, we call them the quantities which are having only magnitude as scalar quantities, which have magnitude and direction as vector quantities. For example, see here, suppose if you start at A and go to the point B, which is 5 meters from A. If somebody starts at A and reaches the point B in certain amount of time, he traveled a distance 5 meters. Let us see like that. Now, if you say that the person traveled 5 meters, you are only mentioning the magnitude of his traveling. How much distance he traveled only you are mentioning. Here, this is simply a scalar. This 5 meters distance traveled is only scalar. Now, suppose from A to B, if you say that 5 meters somebody traveled towards east, if he traveled towards east 5 meters, then you are specifying both magnitude as well as direction. See, magnitude is nothing but the amount, whereas the direction is the direction in which that particular traveling has taken place. So here, as far as this example is concerned, only you have magnitude, which is 5 meters. Here you have both magnitude 5 meters, direction towards east. So automatically here, as you are mentioning both magnitude and direction, we say that this is displacement. The person has a displacement of 5 meters towards east. So definitely we say that it is a vector because it has both magnitude and direction. Whereas here, a person traveled from A to B 5 meters means you are only mentioning distance, which is a scalar. So this is the simplest example to differentiate between scalar and vector. Here you have only magnitude, here you have both magnitude and direction. For example, if you go for speed and velocity, now we say that this person has traveled from A to B, say in 5 seconds. In 5 seconds, he traveled from A to B. And you say that the person traveled 5 meters and the time taken is 5 seconds, that's all. If you say like that, a person traveled from A to B 5 meters and he took a time of 5 seconds, then we say that his speed is 5 meters per second. Here he did not specify in which direction he traveled 5 meters. Therefore, it is only magnitude. You are mentioning the magnitude, which is speed, which is a scalar. Now, if you say he traveled towards east 5 meters in 5 seconds, he traveled towards east 5 meters in 5 seconds, then you are saying the direction also, then we say that this is velocity. Velocity is 5 meters per second. So velocity has both magnitude and direction, speed has only magnitude, so speed is a scalar, velocity is a vector. Like that, you can always distinguish between scalars and vectors in physics simply by identifying the difference between the magnitude and direction. But don't go by this rule always. There are some exceptions. That means you cannot always say that all quantities which have both magnitude and direction are vectors. There are some exceptions where even if a quantity has both magnitude and direction, still it cannot be a vector. I will show you one example. suppose a current of 5 amperes is flowing through a wire. So, here current direction is mentioned, magnitude of current is mentioned. So, both magnitude and direction are there, but still you cannot say that electric current is a vector. The reason for that is it simply does not obey the vector addition of the rule of vector addition. It does not obey the addition of vectors rule. That is why we can just amend the definition of vector by saying that any physical quantity which has both magnitude and direction and obey the addition laws of vectors is called a vector quantity. Otherwise, we can call it a scalar quantity. This is as simple as that. Now, coming back to the utility or use of these vectors in physics, this is the most important concept, because almost each chapter contains some vectors. So, whenever you are dealing with vector quantities in physics, you are always should be familiar, you are always in demand for what are the operations required for vectors. So, once we know what is a vector, we should know what are the operations in vector, how we operate vectors. If we know the operation of vectors, we can apply these operations in various chapters to solve any type of problem wherever vector quantities are involved. So, remember that this is the most important point. The rules of vectors which you are learning in this chapter are applicable to all chapters, both in first year and second year, both in +1 and +2. So, both in junior and senior intermediate. So, that is why you should be very attentive while discussing these laws of vectors or some of the concepts relating to vectors, operations of vectors. So, vector operations involve basically addition, subtraction, resolution and multiplication. These are the 4 operations which we should be familiar, because whenever you come across vectors, you can apply all these operations, any of these operations required in that particular question. So, remember, these are the basic operations: addition of vectors, that means how to add 2 vectors, and subtraction, that means how to subtract one vector from another vector, and resolution, that means how to split a vector into components, 1 component, 2 components, 3 components, etc. That is resolution. Third one is multiplication, means how to get the product of vectors. So, this is the multiplication or product of vectors. Now, one by one we will study these applications. First, we should know what is that concept, addition or subtraction, and then how we apply that in physics. I will give you a few examples also, so that you can always use these operations whenever you require. First of all, if you take addition of vectors, addition of vectors, suppose A is a vector and B is another vector. These are the 2 vectors A and B. You want to know what is the addition of these 2 vectors. To find the addition of these 2 vectors, what we should do is, first you draw vector A and then bring the vector B here and draw like this. That means the tail of B should be at the head of A with its magnitude and direction. You draw vector B starting at the head of A. Now, if you join the tail of A to the head of B, this will give you A plus B. So, this is this vector This vector represents both magnitude and direction of A plus B, which is addition of the two vectors. So, you added the two vectors and you got the vector, the resultant of the addition of the two vectors. So, this will represent both magnitude and direction of two vectors. Now, this value can be known by using a law called parallelogram law of addition of vectors. Suppose this is A, this is B, this will also be B because this is a parallel vector. When you draw a vector parallel to another vector with the same magnitude, that would be the equivalent vector. So, you draw a vector B here, then A and B are representing the adjacent sides of a parallelogram. A and B are representing adjacent sides of a parallelogram. Complete the parallelogram. Then this is the diagonal of the parallelogram. You must be familiar with the parallelogram of addition of vectors. When two vectors are represented by the two adjacent sides of a parallelogram, the resultant is represented by the diagonal of the parallelogram, both in magnitude and direction. So, the resultant of these two or the resultant of these two is this only. See, simply A plus B represented here, this R also represents A plus B. So, if you find the magnitude of R, that is the resultant of magnitude of the resultant of A and B. If you know the direction of R, that is the direction of addition of A and B. So, that is how we find the addition of vectors simply by using the concept of parallelogram law of vectors. After some simplification, suppose between A and B angle is theta. We cannot have the detailed discussion here because of the nature of the syllabus. So, here if the angle between the two vectors A and B is theta, then resultant R magnitude is given by root of A square plus B square plus 2AB cos theta. So, this relation will give you a resultant of addition of two vectors. Resultant of addition of two vectors magnitude, that means modulus of A plus B is nothing but R, which is equal to this. So, this is also called resultant of addition of two vectors. If the angle between two vectors is theta, resultant of addition of two vectors is given by this relation. And to find the direction of R, you can extend this and draw a perpendicular like this, and from this you can find the angle made by the resultant with A. Suppose this resultant makes an angle alpha with A, then by using this relation tan alpha is equal to using this relation, you can find the direction of R. Find the direction means what angle it makes with A or what angle it makes with B. If you can find alpha, you can find angle, this angle also, which is nothing but theta minus alpha. So, if you are finding that angle means you are finding the direction of resultant. So, this relation gives you magnitude, this relation gives you direction. Whenever two vectors are given, to find the magnitude use this relation, to find the direction use this relation. Remember that. This applies to any vectors, displacement, velocities, forces, etc. So, now using this addition, we are able to find the resultant in many cases. For example, there is a body of mass 10 kg which is lying here on a table. Two forces are applied perpendicular. Suppose this is 10 newtons, this is also 10 newtons, applied perpendicularly in perpendicular directions on this body. If you want to find the resultant force on this, that means you are trying to find the addition effect of these two, the compound effect of these two. What you should do is you should apply the relation R is equal to root of P square plus R is equal to A square plus B square plus 2AB cos theta. This relation will tell you what is the magnitude. Apply this formula here also. Here angle between these two vectors is 90 degrees. So resultant will be equal to root of 10 square plus 10 square plus 2 into 10 into 10 into cos 90, which is 0. Cos 90 is 0, so this term becomes 0. This will be equal to 10 root 2 newtons. That means net force acting on the body is 10 root 2 newtons. Like this, to find the resultant of any two vectors, apply this relation. You will get the relation. Suppose if you want to find the direction of the resultant, this is the direction in which the body is likely to move. To find the direction of this, let this be alpha, then tan alpha is equal to q sin theta or b sin theta by a plus b cos theta. Apply this relation. Here b means 10 newtons, sin theta means angle between the two vectors is theta, no? It is 90 degrees, sin 90 is 1, a is also 10, cos 90 is 0. That means 1, tan alpha is equal to 1, alpha equal to 45 degrees. That means the resultant force acting on the body is at an angle 45 degrees to this. That means it is also at 45 degrees to this force. So you find the direction in which the resultant acts. You are able to find both magnitude and direction of resultant if you know this relation and the previous relation. Now, similarly, there are so many other examples. We cannot have complete coverage like this only. Now, let us go to the subtraction part. Subtraction of vectors. So, this is also one of the important concepts which is generally neglected by students. Here, suppose this is A, and this is B. Now, what we are trying to find? A minus B, subtraction of B from A. To find A minus B, you draw vector B in opposite to B. That means with same magnitude as B, exactly in opposite direction you draw. This will become automatically minus B. Negative of any vector is nothing but a vector drawn opposite to its direction with same magnitude. So, negative of B is vector drawn opposite to B with same magnitude. This is minus B, this is A. So, by the principle of addition, it becomes A minus B. So, you got the vector A minus B, or subtraction of B from A is represented by this vector, both in magnitude and direction. So, to find the difference of two vectors, this is difference of two vectors, this is the method we should apply. Actually, this difference of vectors method is also useful in many cases, and to find the resultant of difference of vectors, that means what you are trying to find is modulus of A minus B. Modulus of A minus B is equal to root of A square plus B square minus 2AB cos theta. Remember that. Because here mod of A plus B you can write as mod of A plus of minus B, and you can apply the magnitude formula for addition which we learned previously, then A square plus B square plus 2A into minus B into cos theta, which results like this. So, directly you can apply this formula whenever you are trying to find the mod of difference of two vectors. This is very useful in some cases. Now, let us see one or two examples where this difference of two vectors is useful for us. For example, a particle is moving in a circular path with uniform speed v. A particle is moving in a circular path with uniform speed v. Even though it is moving with uniform speed, direction of velocity is continuously changing like this. It is continuously changing with time. So, you cannot say that velocity is constant. You can say speed is constant, velocity is not constant because direction is continuously changing. Automatically there will be a change in velocity. Even though speed is constant, velocity is not constant, therefore there will be a change in velocity. How to find the change in velocity? To find the change in velocity, we can use this relation. Because direction is continuously changing now, you can use this relation to find the change in velocity. Even though magnitudes are same, but directions are not same. For example, see here, velocity here is in this direction. This is V1, which magnitude is V only, and this is V2, which magnitude is V only, but direction is different. So this is the angle theta between those two, which is nothing but suppose if this is the center, you can find that this angle and this angle will be same. Then you can say that modulus of V2 minus V1 is equal to root of V1 square plus V2 square minus 2V1 V2 cos theta. So, root of V1 square plus V2 square minus 2V1 V2 cos theta is the resultant of the difference of the two vectors, which is nothing but change in velocity is equal to mod of V2 minus V1. Change in velocity means mod of V2 minus V1 is equal to this, is equal to root of, we know that modulus of the velocity is same everywhere, which is nothing but speed. We can write like this. So this is equal to 2V square into 2 sin square theta by 2, that is equal to 2V sin theta by 2. So 2V sin theta by 2 is the modulus of delta V, or resultant change in velocity magnitude. Magnitude of change in velocity is equal to 2V sin theta by 2. Here theta is actually angle between the two positions from where you are trying to find the change in velocity, which is equal to the angle theta made by the radius vector in these two positions. For example, a particle is here, velocity is in this direction V1. When it comes to the opposite, velocity is in the opposite direction. Here, if it is moving with uniform speed, speed is same here and here, but directions are opposite, so velocities are different. Now to find the change in velocity, we will apply this relation 2V sin theta means how much the radius vector traveled by the time it comes here, 180 degrees. So 180 by 2 means 90. So sin 90 is 1. So change in velocity by the time the particle completes half of revolution is equal to 2V. Similarly, if it completes quarter of a circle, its velocity will be like this. The radius vector completes 90 degrees. Then here what you will get is delta V is equal to 2V sin 90 by 2 is sin 45, which is nothing but 1 by root 2. So root 2V. Change in velocity will become root 2V, where V is the speed. Like this you can find change in velocity in case of uniform circular motion. Next, another example which is useful for subtraction is this. Suppose a ship A is going towards east with a velocity 10 meters per second. Ship A is traveling towards east with a velocity 10 meters per second. Ship B is going towards north with a velocity 20 meters per second. there are two ships which are traveling at right angles. One is traveling towards east, another is traveling towards north. Now, if you want to find the relative velocity of A with respect to B or B with respect to A, you can use the same subtraction concept. The reason for using that is this. Generally, if A and B are traveling, A and B are in motion, if velocity of A is VA, velocity of B is VB, then relative velocity of A with respect to B, relative velocity of A with respect to B is defined as VA minus VB. Relative velocity of A with respect to B is defined as VA minus VB, both in magnitude and direction. Because this is a vector, this is a vector, subtraction also gives a vector, which is the relative velocity of A with respect to B. Now, if you want relative velocity of B with respect to A, what you have to write is VB minus VA. You can write like this, VB minus VA. So, relative velocity of one with respect to the other is always possible to write in this way. Suppose if two particles P and Q are moving, relative velocity of P with respect to Q means Vp minus Vq. Relative velocity of Q with respect to P means Vq minus Vp. So, remember that. Now, here A is moving in this direction east, B is moving in this direction north. Now, what we want is relative velocity of A with respect to B. Relative velocity of A with respect to B means VA minus VB. You have to find this vector. There comes our subtraction concept. What you have to find is, what is the vector this VA minus VB? To find this vector, what we should do is, first to draw VA, 10 meters per second. Now, VB, we want minus VB, VB is towards north. So, minus VB you draw like this. See how we are drawing. We are drawing from the head of A. VB is equal to 20 meters per second. This is actually minus VB. Minus VB means direction is in this direction, but magnitude is 20. So, this will be equal to VA minus VB vector. VA plus of minus VB, which is VA minus VB. So, this vector represents both magnitude and direction of relative velocity of A with respect to B. So, what is the modulus of VA minus VB? What is modulus of A minus B? Root of A square plus B square minus 2AB cos theta. So, here also modulus of VA minus VB is equal to root of VA square plus VB square minus 2VA VB cos theta. This will give you the modulus of relative velocity of A with respect to B, which is equivalent to 10 square, VA is 10, VB is 20, no? 20 square minus 2 into 10 into 20 into theta is angle between them, which is 90 degrees, cos 90 is 0. So, this will be root of 100 plus 400, root of 500. That means 10 root 5. 10 root 5 meters per second is the relative velocity of A with respect to B. Now, we got the magnitude of relative velocity of A with respect to B. What we want is direction of relative velocity of A with respect to B. So, for this, let the relative velocity of A with respect to B makes an angle alpha with east. This direction represents east, no? So, here also east. Let the relative velocity of A with respect to B is making an angle alpha with A with east, then tan alpha is equal to, write tan alpha is equal to VB by VA. VB by VA means 20 by 10. So, alpha is equal to, this implies alpha is equal to tan inverse 2. That means the relative velocity of A with respect to B is moving at an angle tan inverse 2 from east. It makes an angle, its direction is making an angle tan inverse 2 from east towards south, So, we got both magnitude and direction using concept of subtraction of vectors. So, remember how we are using this type of techniques should always be used in physics to simplify problems easily. Otherwise, they all look very complicated. This is a relative velocity problem which students always find difficult, but if you know this concept, it can be done very easily. Now, resolution of vectors. After the subtraction, let us go for resolution of vectors. Resolution means, suppose there is a vector A. It makes an angle theta with x axis. This is y axis. Let us take x and y axis like this, and a vector is located like this, making an angle theta. When it is making an angle theta with x axis, we can always resolve this into two components along x axis and along y axis. The component along x axis is a cos theta, the component along y axis is a sin theta. Remember that. The component along x axis is a cos theta. This is angle attached component. You can remember like this. Attached component always will be cos component. Automatically the remaining other component will be sin component. A cos theta, a sin theta are the two components. Now, this length gives you magnitude of the component and the direction is in the direction of x axis. Suppose unit vector in the direction of x axis is I. Then we can say that modulus of Ax is a cos theta. That means component magnitude is a cos theta. In vector form, Ax is written as a cos theta into I. This I indicates direction, which is in the direction of x axis. So, this is complete component of A along x axis. Complete component of A along x axis. Now, similarly, modulus of Ay is a sin theta and Ay vector is a sin theta into j, where j is unit vector along y axis. So, the complete vector A, which is equal to the two components added like this in vector form, is equal to a cos theta into I plus a sin theta into j. So, all are equal. This is equal to this one. This is the complete vector, a cos theta into I plus a sin theta into j. If you want only magnitudes of the components, simply a cos theta and a sin theta. So, this way of splitting the vector into two or three components is called resolution of vectors. Another way of resolving is, you can always resolve a vector into three components along x, y and z axis. In that case, suppose x component is x, y component is y, z component is z. Then we can write the vector A as xi plus yj plus zk. So, with all the three components, you can divide any vector maximum into three components. So, whenever a vector is divided into three components or split into three components, we say that the form in which it is represented like this is called analytical form of the vector. So, this analytical form is sometimes more useful than the geometrical form which you are using so far. So, if a vector is represented in the unit vectors of I, j, k, we call it analytical representation, which will straight away gives you components of the vector along the axis, and you can also find the angle made by the vector with the coordinate axis by the relations which are familiar. For example, if it is given like this, then x component is x, y component is y, z component is z. Angle made by this vector with x axis is represented as cos alpha is equal to x by mod A, and cos beta is equal to x by mod B, and cos gamma is equal to x by mod C. Only there is no B and C. X by mod A, y by mod A, z by mod A. Cos beta is equal to y by mod A, cos gamma is equal to z by mod A. So, using these relations, you can find the angles made by the given vector in terms of the given magnitude and components. For example, x is equal to 2i plus 3j plus 4k. If A is equal to 2i plus 3j plus 4k, A is a vector represented like this. This representation is called analytical representation, as I told you. Here x component is 2, y component is 3, z component is 4. First thing we got, components along x and y z axis are those. Now, if you want a magnitude of total vector, you can use this formula which is familiar, x square plus y square plus z square. This will give you the magnitude of the total vector, which is equal to this value. Count the value. Actually, this will be 4 plus 9 plus 16, that would be root 29. So, modulus you got. Now, to find the angle made by this vector with the different axis, cos alpha is equal to x is 2 by mod A root 29. So, alpha is equal to cos inverse. This is giving angle made by this vector with x axis. Similarly, you can proceed to find the angle made by it with other axis. Means y axis means what we can write is 3 by mod A root 10. Cos beta is equal to 3 by, or beta is equal to cos inverse 3 by root 29. Gamma is equal to cos inverse 4 by root 29, like this. So, you can find like this. So, splitting helps us. Resolution of vector actually is the logic behind this type of representation of vectors and finding angles with coordinate axis or finding components along a given direction. Next, the product of vectors. Product of vectors is, suppose A and B are two vectors, then the product of two vectors can be two types, cross product and dot product. Dot product and cross product. So, dot product means A dot B, which is defined as mod A mod B cos theta. Cross product is defined like this, mod A mod B sin theta into n cap. N cap means actually this is a vector, therefore you can you have to represent this also as a vector. Therefore, you have to represent with unit vector. This unit vector is in the direction of A cross B. A cross B direction is given by this, magnitude is given by this. For dot product which is a scalar, no need of any representation. Now, dot product is useful to deal with scalars, cross product is useful to deal with vectors. That is the major difference. Suppose if you take work is dot product of two vectors, f dot s. Similarly, if you take torque, which is a cross product, torque is a vector actually, torque is equal to r cross f. It is a cross product of radius vector and force. These are the examples for cross product and dot product. So, if you want to deal with products, vector products which are scalars, you are using this relation. If you are dealing with cross products, you are using this relation. Of course, you know how to find dot product and cross product. Familiar methods are there. We can always do, suppose A is equal to some x1i plus y1j plus z1k and B is equal to x2i plus y2j plus z2k. Then A dot B is defined as x1 x2 plus y1 y2 plus z1 z2. A dot B is calculated like this, and using this operation you can find angle between two vectors also. Using this relation, cos theta is equal to, you know that A dot B is equal to mod A mod B cos theta, no? So, A dot B by mod A mod B. So, A dot B you can calculate like this. Mod A means root of x1 square plus y1 square plus z1 square. Mod B means root of x2 square plus y2 square plus z2 square. Therefore, you can use the operation A dot B by mod A mod B to find the angle. To find the cross product, what we have to do here is A cross B you can find by this method. A cross B is equal to, you can do like this, ijk x1 y1 z1 x2 y2 z2, write in determinant form and work out, you will get a cross product, and you will get it in terms of ijk only, which indicates that this is a vector. Cross product is a vector. So, always use the determinant form and calculate A cross B. Now, let us do a few examples. First one, the vector A equal to I plus j, where I and j are unit vectors along the x and y axis, makes an angle with x axis. So, what is the angle made by the vector I plus j with x axis? The meaning of that is that only. So, the vector given is I plus j. What is the angle made by this x axis? We already give the formula for x axis angle made is x by mod A. Here x is 1, xi plus yj form, no, x is 1, and modulus of this is root of 1 square plus 1 square, because y is also 1, no, modulus is root of x square plus y square, that is equal to 1 by root 2. So, alpha is equal to 45 degrees. So, first option is correct. Next to PPT, a man is traveling at a velocity 10.8 kilometers per hour in a topless car. See, you read the question. The velocity of the man is 10.8 kilometers per hour, which is equivalent to 3 meters per second. And rain is falling like this. So, velocity of rain is vertically downwards. Umbrella is held like this at an angle theta. Now, what we want is VR. This angle theta is given to us 53 degrees, and cos 53 is also given to you. Actually, here cos 53 is equal to 3 by 5 is equal to VR by 3. VR by not 3, this one, this is 3, VR is not known, this should be 5. So, automatically this will be cos 53 is given as 3 by 5, 3 by 5. So, this should be equal to 4 kilometers per hour. cos 53 is 3 by 5. So, this is 3, head and side by hypotenuse. If this is 3, this should be 5, then automatically this should be 4. So, the rain is falling with a velocity 4 kilometers per hour. Next PPT. So, here boat velocity, a boat is moving with a velocity 3I plus 4j. So, boat velocity is 3I plus 4j, and the river velocity is 3I minus 4j. What we want is relative velocity of boat with respect to water. Relative velocity of boat with respect to water, already I told you, should be written like this: VB minus VR. VB is this, VR is this. So, VB minus VR is equal to 3I plus 4j minus 3I minus 4j, which is equal to 8j. So, 8j is the answer, which is third option.